So let's look at SO2, another nice molecule. So which one's going to be the central atom? Clearly it's sulfur, it's below oxygen. It can form more than 2 bonds. It can expand its octet. So I'll do this to start out with. Now sulfur has 6 and oxygen has 6, that's 12, total 18 electrons. So 2, 4, 6, 8, 10, 12, 14, 2, 4, 6, 8, 10, 12, 14, 16, 17, 18 electrons. That should do it. So right away I run into problems. -1 charge here, -1 formal charge here. Sulfur normally has 6 valence electrons. So for the sulfur formal charge, I have 6 valence electrons -1, 2, 3, 4, +2. So 1 for here, 1 electron for here, and 2 for here. 4 total electrons when we're counting for valence charge. So it's +2, so the total charge is 0. So that's okay. But what are my problems? Right off the bat, this only has 6 total electrons, so the sulfur is low on the octet rule. It does not like to be that way. Nothing really likes to do that except boron and hydrogen, and perhaps beryllium. So that's not good. So we can do some things. I could move an electron pair in. So how about this? I didn't change the number of electrons. I just moved them around. Now sulfur has a total of 8 electrons on it. And oxygen has 8, and this oxygen has 8. And I have, this gets messy. Let me erase it. I have S with an oxygen around with a -1 charge, double bond over here, and an extra pair. So -1 charge, sulfur now has 3 bonds. It's allowed to do that. Remember, it can form more than 3 and can have extra electrons. Right now it has 8 electrons on it. So it's happy. So I also have formal charge. So the formal charge for the sulfur is equal to 6 minus, when I count them, 1 for this one, 1 for this one, 1 for that. That's 3, 4, 5, 6 and -5 equal +1. So my total charge, I put a little +1 there, is 0. So you would write this. After all this work, you've got to clean it up. If you give anything as messy as this thing up here, you're down to tubes. +1 for the sulfur. That's a viable. Are there any others? What about this thing? Oops, left the electron pair off. So there we go. That's a viable dot structure. How about this thing? Still have total 18 electrons. That's good. Do I have any formal charge? Well, the oxygen has 2 bonds, so I know its formal charge is 0. Formal charge here is 0. How about the sulfur? Sulfur typically has 6 electrons. Now when I count these, I get 1, 2 for this bond, 1, 2 for that bond. That's 4, 5, 6. -6 equals 0. That looks like a pretty good structure. We've minimized the formal charge in this structure. We don't have any, okay? But we have gone to 2, 4, 6, 8, 10 electrons on the sulfur, which it's allowed to do because it's in the 3rd row. Once you get into the 3rd row, you can have more than 8 electrons on a particular atom. So both of these would be good resonance structures. And you could use either one to get you credit for a Lewis dot structure.